Hello, my name is Ramon da Silva. I am a PhD student at Pontifical Catholic University of Paraná, PUC-PR, in Brazil. And today, I'm going to present you the paper entitled Electricity Energy Price Forecasting Based on Hybrid Multi-Stage Heterogeneous Ensemble Brazilian Commercial and Residential Cases. So the agenda of this presentation is going to be the introduction, the objectives and the contribution, the data sets description, the methodology, the results obtained, the conclusion, and the reference at the end. So electricity power systems plays a key role in the society economy. High frequency, volatility and seasonality are price data features, and these features make the forecasting process hard. Therefore, ensemble learning models can be adopted to deal with these features. Beyond that, hybrid ensemble heterogeneous models are effective tools. So the objective of this paper is to propose a hybrid heterogeneous ensemble learning model to forecasting Brazilian electricity prices multi-step ahead, which means 1, 2, and 3 months ahead. Hybrid approaches, in this hybrid approach is composed by complementary ensemble empirical mode decomposition, CEMD, coyote optimization algorithm, COA, and heterogeneous ensemble of the components. So the contributions of this paper are stated as the proposition of a self-adaptive decomposition approach for electricity price forecasting. Also, is the first use of the combination of both CMD and COA approaches. And finally, the evaluation of the decomposed homogeneous and the heterogeneous ensemble learning models for electricity price forecasting. So the electricity price time series ranges from April 1994 to September 2019, both for commercial in the left and residential data in the right. Each dataset is composed by 306 monthly samples, and the measure of the electricity price is a Brazilian currency by megawatt hour. And the data sets were split into training and test sets with the proportion of 70 and 30% each. And it's important to highlight that the high value presented by the residential electricity prices in October 2013 can be seen as an outlier, and it can be attributed to the climate, political factors, or even by the measurement errors. So the methodology of this paper is the following steps. The CMD preprocesses the data into 4 different components. The COA optimization tuned the CMD hyperparameters, and finally the heterogeneous model with trends. The heterogeneous model are the extreme learning machine, the Gaussian process, the gradient boosting machine, and the relevance vector machine. In the performance measure, relative root mean square error and mean absolute error were used, and the Bode-Mariano test as statistical test. Also, table 4 shows that models that compose the proposed models for each dataset and forecasting horizons. In this slide, each plot presents the original data split into 4 different components. They represent different frequencies of the data and the trend. And the behavior observed in the residual component of both series is due to the growing trend in the prices. For the first experiment, the proposed approach outperformed the homogeneous ensemble learning models in all criteria and all forecasting horizon for both datasets. These results is due to the diversity of the model's features. Once different models can learn different data features and then enhance the forecasting accuracy. And the performance of the proposed model was excellent once they achieved errors lower than 5%, as we can see in table 6. Same for experiment 2, the proposed model was also outperformed the single models for both datasets and all forecasting horizons. And these results are due to the fact that the decomposition approach removes the noise of the data. It's important to highlight that Gaussian process model presented competitive results compared to the proposed. In the above-Mariano test results, the proposed models has statistical low errors than most of the compared models, with exception of the homogeneous COA CMG Gaussian process for 2 months ahead, as we highlight in the table 8. About the results, the predicted versus the observed electricity prices, the proposed model learned the data pattern for both training and test sets in both data sets in all forecasting horizons. The models could not capture the outlier presented in residential cases, as you can see in the plot in the right. So we can conclude that the hybrid multi-stage heterogeneous ensemble model was proposed to forecast multi-step ahead, 1, 2, and 3 months ahead for Brazilian commercial and residential electrical energy price. Some limitations occurred in this paper. First, the political climate and demand factors were not taken into account in this data analysis. Second, the proposed model was not able to capture the variability of an extreme observation for the set of the data referring to the price of residential electricity. And third, the parameters of the COA optimizer were selected by trial and error. Heterogeneous ensemble achieved better forecasting accuracy than homogeneous ensemble, and COA CMG heterogeneous model is better than no decomposing models regarding forecasting accuracy. Here are some references used in this presentation. And we, as acknowledgements, we would like to thank you, CAPES, CNPq, Fundação Araucária, e PUC-PR for financing this work, for support financing this work. And thank you for watching this presentation. See you next time. Goodbye.